Good evening, everybody. I'm going to cover drafting. Since we did this in class, I'm not going to dwell on it or spend nearly as much time on it as we did in class, but I do want to try and explain what drafting is a little bit better. I feel like when we talked about it in class, we were mostly focusing on the tools. I tried to explain about molds a little bit, but at this point I just want to state drafting is not a set of tools that you use. There are tools that will help you draft a part, but in the same way that if you were designing a part for ergonomic purposes, this had to interact with a human body in some way, your focus would be on the body and the part's interaction with the body. In the case of something that's injection molded, our focus is on the mold. This part has to exist in real life. It's made out of a rigid material, and it's going into a mold that can't deform. It's not squishy enough to get out of the way. So we have to make sure our part doesn't get stuck in there. And thinking like a mold, thinking like the tool, is the best guide for knowing how to draft your part. And then knowing which drafting tools to use, that'll just help guide your modeling flow. But your eyes on the prize is to be able to get this thing out of some injection molded tooling. So here I have two master sketches already set up. Got one on the Y, the plane perpendicular to the Y, that's the top plane, and then on the front plane, which is perpendicular to the Z axis, so I've named them accordingly. This should all be pretty familiar at this point. So I'll go through it quickly. I'm converting lines from my master sketch. I'll trim off the excess. And what we would have done up until this point is to create an extruded feature, like so. I've used, as you can see, I've used this height reference in my front master sketch to tell me how tall to make that part. But instead, because I want to be able to pull this down out of a mold, I'm going to turn on my draft feature. So that's method number one, is to create extruded bodies with draft angles built in. You can draft inward or outward. It's inward by default, and I'm going to leave it like that. Check mark, and now you can see these edges are not vertical. That means that this will be able to slip downwards out of a mold. Okay, and there are a couple of other methods we can use. So I will put this square hole up from the bottom. So I'll start my sketch on the top plane. I'll borrow these lines from the master sketch. And now I'll do an extrude cut. How far? Well, I've got a sketch for that. So I'll select this point that I specifically created for this feature. And now, if I view this from the side, you can see those lines are vertical as well. And we know lines that are parallel to the direction of pull, which is to say I'm going to pull this part, I'm going to pull the tool that creates this feature down out of the part. These parallel lines will cause a lot of friction and potentially damage our part or our tool. So I'll throw a draft angle on there. So that's method number two, is to create cut parts which are drafted by default. Now you can see these lines are not vertical, instead they're going outwards. Now that we've created this drafted square hole on the bottom, I'll use a different method to create a circular hole centered on this circle drawn on the top master sketch. Because the center of this revolve cut feature is going to lie on the front plane, I'll select my front plane to draw the profile. I'll reference the center of the circle on my top master sketch. Looks like I wasn't able to click it. That coincident. There we go. I'll make that into real sketch geometry. I'll draw a construction line horizontally to this line which drives the overall height. That way I'm guaranteed that my feature is the correct height. Remember, we're doing a revolve feature here, so we only need to draw half of it. Now we covered this briefly in class, but it is important, so I'm going to go over it again. This circle, which is where I'd like to have this line connect, that circle, when viewed from the plane in which we're currently sketching, is indistinguishable from a line. So though it looks like a circle from the top, from our point of view, it's merely a line segment. And so if I tell SOLIDWORKS to make this endpoint coincident to that line segment, SOLIDWORKS just makes it, it constrains that point to be along the line, so I can't move it up or down, but it doesn't particularly care where it is left or right. So that's not really good enough for our purposes. Instead, we use a more specific command, a more specific relation, which is only an option when you have geometry on two different sketches that occur at different, rather that are drawn on different planes. So the circle's on the top plane, and this point is on the front plane. And if I want them to actually physically touch each other, I can use my pierce constraint. And that will force this endpoint to be at the intersection between the plane on which we're sketching and the other sketch geometry I had selected when I applied the pierce constraint. So there you go. And then because we're talking about drafting here, I'll dimension this line with an angular dimension. Turn off my sketches. And there we have the basis for our revolved feature. I'm going to use a cut revolve. And you can see SOLIDWORKS, because there is a construction line in the sketch, it assumes that's where I want to revolve it around. Not really what we intended. Thanks for trying, SOLIDWORKS. Let's just deselect that. So I'll right click up here where it says axis of revolution. I'll hit clear selections. And instead I'll select the center. As you can see, that line lies in the center of the circle on the top master sketch, and so it'll be the center of our cut revolve feature. Completing the feature generates our cut revolve geometry, which, as you can see, is tapered in this direction. So there we have, we can extrude a body with a taper, or rather with a draft on it. We can do an extruded cut with a draft on it. We can simply revolve geometry as we see fit to have the appropriate draft angles. And finally, there is a draft feature. So if I had failed to do any drafting, say I extruded my beginning feature with no draft on it, I extruded my cut feature with no draft on it, and I created my revolve cut feature with no draft angle on it. At the moment, I wouldn't be able to pull this out of a mold, because as you can imagine, a mold with a pin inside of this cylinder trying to slide up is going to be dragging along this surface. It's going to be dragging along this outside surface here because they're all parallel to the direction of pull, which is to say, as we're yanking this thing out of the mold, it doesn't get any easier to take out. So the final drafting tool is called the draft feature. It lives up here. It's called Draft Expert. Tell you what, there we go. Make it a little bit easier to see. It lives right here. It's called Draft. For now, I'll set it to manual. Draft Expert makes it a little bit easier if you're going to be drafting many things. But since this is a simple, relatively simple part to draft, I'll select manual. For my neutral plane, I'll select the top plane, and the direction of pull, that is the direction in which the mold will be yanked off of our part. So I'm going to draft all the things that I want the top mold to create. I don't need to draft this top surface because it's already perpendicular to the mold. There's going to be no problem pulling this off of a mold. It's only these vertical surfaces which have to slide out of the mold cavity. I'll also select this interior surface, and I'll select my draft angle to be 2 millimeters. There we go. You can see by applying that feature, I can roll back to temporarily turn it off. That's where we started. That's what the draft feature created for us. That's exactly the same result that we got by specifying the draft within the boss extrude feature itself right here. The end result is the same. A good way to tell if you've got something drafted in a way that you'll be able to pull it out of a mold is to do the line of sight test. So if I view this part from the top, boop, I can see all of these faces along the side. I can see this face. Now if those faces weren't drafted, we can simulate that by turning the draft off. Now I can see the edge, but I can't see the face. If a part is drafted in a particular direction, in this case from the top, you'll know if you're able to pull something out of the mold basically based on whether or not you can see it. The SolidWorks draft analysis tool found in View, Display, Draft Analysis does exactly that same thing. Just basically looks and checks to see if it can see the face. Now, it works a little bit differently, and it will give you some potentially confusing results if you have more complicated geometry, but without using the draft analysis tool, the best way to do your draft analysis is just by using your eyes. So I'm going to flip this part over. Now it's upside down. And it looks like I can't see any of these outside edges, and I can't see these edges, or rather these sides. Can't see those from the bottom, but that's okay because I can see them from the top, which means that I can pull them off of this side. They're going to be on the top tool. But on the bottom tool, the bottom half of our mold, I'm going to need to create this feature because I sure can't create stuff down here with a mold that's up on top. So this is going to have to pull down off of the bottom. And in order to do that, what I know from my vision check is to say I need to be able to see these sides. These sides need to be drafted. So in order to draft them, they'll be drafted in a different direction from the top because we're pulling the tool off in a different direction. I'll use my draft tool again, and I'll select the bottom face as my neutral plane. I'll leave my draft angle set at 2, and now I'll select these faces. I can check that by using my section tool, and there you have it. Another way to check it is what we just talked about. I'll view it from the bottom, and after drafting it, I can now see these faces, which means I'll be able to pull them straight off of a mold. So we can extrude bosses with the drafts turned on. We can cut with drafts turned on. We can do revolves, both revolved bosses and revolved cuts, where we're simply tapering the angle that we're drawing in our sketch. That'll result in a tapered feature. Or we can use the explicit draft tool, which is made just for this purpose. These basic tools are in addition to choices you'll make while surfacing or choosing where to place features. Just because a face is drafted in a particular direction doesn't necessarily mean you'll be able to get it out of a mold. For example, if I happened to very sloppily and poorly draw a circle and cut into my mold, I could hit the draft check mark. That's fine. But logic will tell me, oh, hey, too much. Sorry about that. 10, thank you. Logic tells me that even though this surface is drafted, if I want to have a mold with only two parts, a top part and a bottom part, I'll never be able to get that mold out of here. Any feature in our tooling, in our mold, that's going to create this indentation is going to have to be pulled out in this direction. And if I'm only pulling from the top and the bottom, that's not going to work. So yes, you can solve potentially difficult part drafting questions by adding more pull directions onto your tooling. That also adds cost and complexity to the manufacturing process. In the case of this class and this week's homework, or the next 2 weeks' homework, we are we're going to be doing two-part molds. This is the easiest thing. It's the best way to get accustomed to the molding process, and it's the easiest thing to do. Maybe easy isn't the right word. It's the most possible thing to do the first time through molding. So real quick, I'm just going to show you a couple of other parts that I made. So this is, it's a little bit more complicated, which is to say it has more stuff going on. It's not a particularly advanced part. It's just got a lot of features. Extruded, filleted the edges, cut the bottom out, do a cut revolve to change the profile, cut some holes here, here, and here, and then extruded those two bosses. Some more fillets, some chamfers. Up on top, I drilled some holes and put some chamfers and fillets on there. And all of those features were made using the same tools and techniques that I just showed you on that basic cube or rectangle with the square and the circle cut out of it. So my extruded holes, I used these with a cut extrude feature. You can see I've got my draft turned on here. These were extruded bosses. You can see I have my draft turned on here. There's an interesting little check mark that says draft outwards versus draft inwards. Usually you'll draft inwards, but in certain cases, for example here, I'm extruding these from the top plane upwards into the bottom of this object. And if I'd drafted inwards, they'd be going the opposite direction I wanted to. This would be very impossible to pull off of a mold. Instead, I'll draft them outwards so that they're wider at what I'm calling the base. I'll roll back before that fillet. You can see they're wider here than they are here. So whether you draft inwards or outwards, it's just a matter of how you have your part set up, but just make sure that you don't have any what we'd call an undercut. And that you can see all of the faces from the view that represents the direction of pull of your tool. To simulate what this would look like in a tool, I've created a quick representation of a mold. You can see we have the negative of the top and bottom, and we can pull these down onto our part. Using our section tool, we can take a glimpse inside, and this is what you should be envisioning as you're thinking about your part. When I talk about a direction of pull, I mean this is the top part of the tool and it's pulled off in this direction, and this is the bottom part of the tool and it's pulled off in this direction, and so everything is getting narrower as the tool gets deeper. That's our way of guaranteeing that the tool doesn't get stuck. And here, a quick illustration of, this is a goofy little part that I made. What it is it's a triangle at its center, and it makes its way out to circles on the ends. There you go. Now this would be quite difficult to make with two-part tooling. Why? Well, because, sorry, let me turn the rest of my planes on here. There, we have our front plane. So if I view this from the front, I can see a lot of these faces, but it looks like in here, this area, it's going to be tricky. I can use the SOLIDWORKS Draft Analysis tool to help me verify that. I'll select the front plane. I'll go to View, Display, again, Draft Analysis. And there you can see. So the blue stuff is all easy breezy. The red stuff would have to be done with a second tool, but now you can see there's a big swath of orange, which is to say yeah, it's not necessarily a negative draft angle. It's not sloping away from us, but it's also not sloping towards us, which means it's going to be difficult to pull this out of a tool. At least a tool that's configured the way that I have my view set up. So what I can do instead is use 3-part tooling. Now this isn't something that we try to accomplish with molding right now in class, but just know that as designers you have this option open to you for parts that require it. You can create tooling with more than just 2 pieces. Some surprisingly common items are actually created using some really complex tooling. If you ever have a chance to tour an injection molding facility, take that chance. Otherwise, jump on YouTube and watch some injection molding videos. They have some pretty cool cutaway animated models, not too hard to find. So yeah, that does it for drafting. I hope this helps. Please shoot me your questions. I've been getting some questions. I've been doing my best to answer them and send back examples. If you have questions with other SOLIDWORKS projects you have, that's fine too. I know surfacing, which we covered a little bit of, there are a million questions you could ask, so please feel free to send them my way, and I'll do my best to turn them around as quickly as possible. I hope this is helpful. Everybody have a good evening and a good weekend. Cheers.